So the average wait time to get seated at a popular restaurant in the city on a Friday night is 11 minutes. Is the mean time different for men who wear a tie? Wait times for 13 randomly selected men who were wearing a tie are shown below. So there's the time. So they're giving us data, aren't they? What can be concluded? All right. So first off, is this a P or U? Is it a percentage or an average question?
Average.
There it is. Second word, average. So it's average. It's not P, it's average. Right. Easy to spot on the test, I think. Okay. And so, and so for average, that means it's going to be a t-test. You can look on the notes. It's always a t-test. Here, I'll show the notes real quick. For the average, there it is. So for all the mean, which is average, it's always t-test. T-test. All right. So we know it's a t-test. And they want us to explain the null and the alternative. So, the claim. I forgot about the claim. Claim is always most important thing, first thing. What's being claimed on this one, or questioned, or tried out on this one?
Is the wait time different for men who wear a tie, or like different?
Yeah, right. Yeah. So, is the mean wait time different? So what do we do with different? What is different? Is that greater, less, equal, not equal? What's different? Remember, different is not equal. Because you can't say it's greater or less. You're just saying it's not the same. It's not equal. It's different. Different than what? Different than 11. Whoop. I moved the screen there. Different than 11, right? Because the average wait time is 11 on a Friday night. Is it different? So different is not equal. Okay. So HO, HO is always equal. Always equal. And so then one of these two has to be the claim, so it must be the other one. Not equal, right? And this one is the claim. This takes, as you know, weak evidence. This one's strong evidence. Always, HO is always weak. H1's always strong. Notice one of those two has to be the same as the claim. The claim is the same as H1. All right, we go to our calculator. But what do we do on our calculator? Well, first you have to go stat, edit, enter. So you got to go into the stat editor, and then you got to go to the top of L1, press clear and enter to clear away the whatever old data was in there, and then put the data down L1, put this data right here down L1. And then you press stat again. Let me put the data down first off. These are the wait times for the men who were wearing the ties. All right, then you press stat. Then the second time you go over to tests. And you go down to the t-test. And you press enter. And then you choose data. Because this time you're basing your information, your results off data. Enter. All right, and then they'll give you the boxes. And the boxes will be mu sub 0, the lines I mean, list, and frequency. So the mu 0 is 11. That comes from the H0 every time. And the list is L1. The frequency is 1. And then I'm going to choose not equals and hit enter. Because that comes from H1. All right, and then you get your numbers. I'm getting my p-value, my t, first off, my t. T is negative 1.379. I had to round it. And my p-value is 0.1931. 1931. The alpha level they wanted me to test at, alpha is 0.05. So the question is, how does my alpha compare? Well, clearly my alpha, or my p-value is greater, right? Alligators open mouth towards the bigger one. Want to eat the bigger one. 19 is bigger than 5. So my p-value is not low. P is not low. So HO, I just don't have any room here. Let me write it over here. P is greater. So P is not low. P is not low. So HO does not go away. Right? That's our conclusion. We fail to reject HO. Fail to reject HO. We keep HO. We're going to keep HO. We're failing to reject HO. P was not low. The P is the percentage chance of luck. The percentage chance of luck was not low. It's a 19% chance, right? Right here. 19% chance it was just luck. So we got these 13 guys and we put ties on them and got the wait time. The wait time came out a little different, but there's a big chance it was just luck because that was only 13 guys and the average, I guess the average didn't come out that different. That's what the calculator says of the data, that the average just did not come out that different. There's a 19% chance this was just luck. That's too big of a chance. They wanted us to test at the 5% chance of luck. Anything more than a 5%, they didn't want us to believe the results. So 19% is too big a chance of luck. We think, no, the P is not low. The null does not need to go away. We fail to reject the null. We keep the null. So we're just going to keep the null here. Our conclusion is, whoops, I'm a little sloppy. Our conclusion is to keep this null and we reject the H1 here. We keep the null. And so which means we believe there's weak evidence, but the average is still the same. It's equal. We believe whether you wear a tie or not, it's going to be about the same wait time. We don't think there's strong evidence that that changes the wait time. So what's our conclusion then? Is not significantly different? Right. Yeah, not. It's equals. So it's not different. Is different? No. Is not? Yeah, that's right. So it's either the first one or it's the third one, on mine anyway. How do you know which one? Statistically insignificant evidence to conclude that the population time is equal to 11. No. There was insufficient evidence to conclude that it was different. There we go. It's the top one, right? There wasn't enough evidence. Whoops, I messed that up. There we go. So we are going with this one. This is the correct one. Here we go. Right? There was insufficient evidence to conclude it was different. So that is the right answer.